While Western military analysts debated whether Ukraine could survive another year of grinding attrition, Ukrainian engineers were quietly building something extraordinary. The weapons Ukraine is deploying for 2026 represent a fundamental shift in modern warfare. I'm Sophie Hart, and this is Sophie Hart Reports. Today, we're examining 5 categories of Ukrainian weapons that are rewriting the rules of 21st century combat. Interceptor drones that hunt other drones mid-flight, armed ground robots operating without soldiers present, Indigenous long-range missiles striking hundreds of miles into Russian territory, laser weapons engaging targets for pennies per shot, and artificial intelligence systems that process battlefield information faster than any human operator. If you want to understand where modern warfare is headed, subscribe to Sophie Hart Reports and hit the notification bell. The future is being written on Ukrainian battlefields right now, and what we're seeing has NATO strategists both impressed and concerned. Let's break down exactly what's coming, why it matters, and why Russia's generals are scrambling to respond. In October 2025, President Volodymyr Zelensky announced that Ukrainian interceptor drones were achieving a 68% success rate against Russian Shahed attack drones. That single statistic represents more than operational effectiveness. It signals that Ukraine has solved one of modern warfare's most expensive mathematical problems. The economics here are brutal. A single surface-to-air missile can cost up to $4 million. The Shahed drone it destroys costs Russia somewhere between $20,000 and $50,000 to produce. By mid-2025, Russia was manufacturing approximately 2,700 Shaheds monthly, plus an additional 2,500 decoy drones specifically designed to drain Ukrainian air defenses. Translate that volume to missile defense requirements, and you're burning through more than $10 billion monthly. That's not sustainable for any military, even with Western support. Ukraine needed a different answer. The answer came from Ukrainian innovation at remarkable speed. The Sting Interceptor from Wild Hornets can reach speeds exceeding 315 kilometers per hour, nearly 3 times faster than the Shaheds it hunts. Built with a 3D printed bullet-shaped frame and 4 rotors, each Sting costs approximately $2,500. These systems use thermal imaging to track targets at altitudes up to 3 kilometers. The doctrine is simple. Interceptors either ram into incoming threats or detonate proximity charges. Unlike anti-drone rifles that require line of sight and constant operator attention, interceptors can hunt semi-autonomously using onboard AI for initial target detection before handing control to human operators for final engagement authorization. By late 2025, multiple Ukrainian companies were manufacturing interceptor variants. Wild Hornets, General Cherry with their Bullet Interceptor, and others scaled production rapidly. President Zelensky announced Ukraine's goal to field 500 to 1,000 interceptor drones daily by late 2025. The need for this scale becomes clear when you examine Russia's attack tempo. From June through December 2025, Russia averaged approximately 180 Shahed-type drones per day. On September 7th, Russia launched more than 800 drones in a single night, the largest attack since the invasion began. Traditional air defense simply cannot sustain that operational tempo. The ammunition costs would exceed Ukraine's entire defense budget within months. Interceptor drones costing $3,000 to $5,000 each suddenly make economic and strategic sense. Success rates vary dramatically based on pilot skill and conditions. According to experts from the Come Back Alive Foundation's Drone Fall program, hit rates range from 30% for newer systems and operators to as high as 80 or 90% for the best-trained pilots with optimized equipment. December 10th, 2025. Near Kostiantynivka in eastern Ukraine, thick fog blanketed the front lines. Aerial drones stayed grounded. Even thermal optics struggled through the dense white haze. For a Russian MTLB armored personnel carrier, it seemed like the perfect moment to rush forward with an assault team. The Russians didn't know a Ukrainian droid TW-12.7 unmanned ground vehicle was waiting. Armed with a 12.7mm machine gun, the tracked robot sat in a pre-established kill zone covering the road approach. Its operator sat more than a kilometer away, watching through cameras and thermal sights. Short, controlled bursts punched through the MTLB's side armor, striking crew and infantry. The damaged vehicle lost steering and rolled within centimeters of the robot before additional fire into the rear troop compartment finished the engagement. No Ukrainian soldiers were exposed to direct fire. The assault was stopped before it began. This wasn't an isolated experiment. Ukraine's 5th Kyiv Assault Brigade documented what developers claim is the first instance of an unmanned ground vehicle independently destroying an enemy armored vehicle in active combat. But that December engagement represents just the beginning of Ukraine's ground robot revolution. In a documented case from the 3rd Assault Brigade, a droid TW-12.7 held a strategic intersection alone for 45 consecutive days. The unit commander described daily operations that constantly suppressed Russian movement attempts. Russian forces made multiple attempts to destroy the system. All failed. Ukraine delivered approximately 15,000 unmanned ground vehicles in 2025. Plans for 2026 call for more than 20,000 units across all types, representing a dramatic scaling from just hundreds of experimental systems months earlier. The platforms vary dramatically in size and mission. The Lyut represents the lighter end of the spectrum, a 4-wheeled platform armed with 7.62 or 12.7 millimeter machine guns. These excel in combined operations where UGVs work alongside aerial drones. Heavier systems like the Termit can carry up to 300 kilograms of payload across various terrain. Its low profile and track design allow operations in conditions that would bog down wheeled vehicles. The modular design supports combat modules, medical evacuation configurations, or specialized engineering equipment. The Maraca prioritizes communication resilience with multi-channel control architecture. Even if Russian electronic warfare knocks out some channels, the robot continues operating. With a carrying capacity exceeding 500 kilograms, it's become a premier battlefield supply vehicle. The numbers tell the story of national priority. Ukraine's government contracted approximately $150 million in UGV procurement for just the first quarter of 2025. That represents a 60-fold increase in spending compared to the same period in 2024. By November 2025, BBC reporting indicated that up to 90% of supplies to Ukrainian frontline positions around Pokrovsk were being delivered by unmanned ground vehicles. These systems are more difficult to jam electronically than aerial drones and far harder to spot than trucks or armored vehicles. Victoria Honcharuk, Director of Defense Tech at the Snake Island Institute, predicts that by the end of 2026, we'll likely see UGV versus UGV engagements on the battlefield. Robot fighting robot. That's the trajectory Ukraine is accelerating toward. While ground robots handle tactical operations, Ukraine's missile program addresses strategic reach. The Sapsan ballistic missile, also known as Hrim-2, represents the apex of Ukraine's journey from complete dependence on Western weapons to indigenous long-range strike capability. With a confirmed combat-tested range of 300 kilometers and potentially up to 500 kilometers for domestic variants, the Sapsan flies at Mach 5.2. That's faster than the U.S.-supplied ATAC-MS, which tops out at Mach 3. The 480-kilogram warhead provides genuine bunker-busting capability against hardened targets. In December 2025, President Zelensky confirmed that Ukraine had begun using Sapsan in combat operations against Russia. He declined to reveal how many missiles were deployed or what they struck, stating that Ukraine doesn't want the enemy to know all the details. The Neptune cruise missile began its operational life sinking Russia's Moskva cruiser in April 2022, marking the largest warship lost in combat since World War II. That success proved Ukrainian engineers could adapt weapons for new missions. By 2025, the long Neptune variant extended range to approximately 1,000 kilometers, roughly 3.5 times the original's reach. The upgraded missile carries a 260-kilogram warhead compared to the original's 150 kilograms. In November 2025, Ukraine used long Neptunes in a massive strike on Russia's Novorossiysk oil export facilities, forcing suspension of operations at the Sheskari's terminal. The attack demonstrated Ukraine's ability to hit Russia's economic infrastructure hundreds of kilometers from Ukrainian territory. The Palianitsia represents something entirely new in Ukraine's arsenal, a hybrid between cruise missile and long-range attack drone. Launched by solid rocket booster that jettisons before a turbojet engine takes over, the system costs less than $1 million per unit. Named after traditional Ukrainian bread that doubles as a linguistic test, Russians typically struggle to pronounce it correctly, making it useful for identifying infiltrators. The Panicking has a range of 650 kilometers, cruising speed of 900 kilometers per hour, and carries a 100-kilogram payload. Defense Minister Rustem Umerov announced serial production began in December 2024, with Lithuania committing 10 million euros to support manufacturing. The system went from initial design to combat deployment in just 18 months. The strategic calculus behind domestic missile production is straightforward. Western weapons like Storm Shadow and ATACMS come with restrictions, both political limitations on targeting and supply constraints based on Western production capacity and willingness to provide. With domestic weapons, Ukraine can strike any military target in Russia it deems necessary without seeking approval from Washington, London, or Paris. That strategic independence is worth more than the weapons themselves. The economic advantage proves equally critical. While precise Ukrainian production costs remain classified, the Panicking costs less than $1 million per unit, significantly cheaper than Western cruise missiles running $1.5 million or more. Ukrainian Reserve Colonel estimates suggest some systems cost $50,000 to $100,000, though these figures remain difficult to verify. Brave One, Ukraine's state-backed defense technology platform, has placed artificial intelligence at the absolute center of its 2026 strategy. With over 200 companies operating inside its ecosystem, Brave One is creating an entirely new category of warfare where machines process information at speeds that make human decision-making obsolete for certain tasks. A Brave One representative explained the urgency simply: Ukraine is fighting an enemy larger in manpower and resources, so maintaining a technological edge is existential. But this is also a race. Russia is actively developing its own AI-driven systems with Chinese technical assistance. The applications weave through every warfare domain. Autonomous target identification allows drones to recognize and classify military vehicles, distinguish between civilian and military targets, and prioritize threats without human input. Optical navigation enables drones to navigate using visual landmarks when GPS is jammed, following roads, rivers, and terrain features the way a pilot would, but processing that information exponentially faster. To accelerate AI adoption, Brave One and the Defense Ministry launched dedicated competitions with budgets up to $2.5 million per solution. Priority areas include fully autonomous drones with complete mission autonomy, thermal and guidance modules for Interceptor drones, AI systems designed to counter Russian glide bombs, and simulation environments for training AI combat systems. Drone swarming represents AI's most dramatic application. Instead of individual drones under separate human control, swarms of dozens or hundreds coordinate in real time. They communicate among themselves to understand spatial positioning and operate as collective intelligence. One operator could control 50 drones simultaneously, launching complex attacks that overwhelm defenses through sheer coordinated numbers. The ethical implications remain largely unaddressed in Ukraine's rush to deploy these systems. Questions about autonomous weapons making lethal decisions, potential AI mistakes that kill civilians, and long-term implications of machine-driven warfare are set aside as Ukraine focuses on immediate survival. But the technology being developed in Ukrainian workshops and tested on Ukrainian battlefields will define 21st century warfare far beyond this conflict. 4 years ago, Ukraine fought Russia's invasion with Soviet-era weapons and desperate improvisation. By 2026, it's fielding weapon systems that were considered science fiction just years earlier. Interceptor drones hunting at 3 times their target's speed. Ground robots holding defensive positions for weeks without human presence. Ballistic missiles striking at Mach 5. Laser weapons engaging threats for dollars per shot. AI systems coordinating swarms of drones. Russia's generals watch these systems deployed in real time, and they understand the implications. The 3-day special military operation that was supposed to decapitate Ukraine's government has instead created a crucible forging the most technologically advanced battlefield military on Earth. And here's what should concern everyone paying attention. These 2026 weapons are old news by the time we learn about them. Ukraine has every reason to keep its most advanced systems classified. We'll likely see even more developments throughout 2026 and beyond. The weapons Ukraine fields in 2026 will define how wars are fought for the next generation. NATO is taking notes. China is taking notes. And Russia is desperately trying to counter systems that didn't exist 3 years ago, developed by a country they assumed they'd conquered by now. This is Sophie Hart Reports. If you want to understand where modern warfare is headed, subscribe and hit the notification bell. Drop a comment below with your thoughts on Ukraine's technological revolution. And if you want to learn more about how this war has reshaped military strategy, check the video links in the description. Thanks for watching and stay informed.